Okay, so we are 1.1, finishing up those notes, right? So we reviewed, I'm going to review real quick. Distance is the absolute value, yes?
Yes.
Okay, is the absolute value of the distance between the two coordinates. This is how I'm always going to tell you. Put the coordinate that is furthest to the right on the number line first. Always. And when we do things, don't we always take the last one minus the first one anyway?
Yes.
Y2 minus Y1? Because we're finding a distance between the two. So if you do that, you won't have to worry about saying, oh, I got -8. Oh, it's really 8. Because we talked about distances in a negative. We don't say go back -6 feet. Or we don't say go -6 feet. We go back 6 feet or right 6 feet or left or whatever. Okay, so what is the length of CD? So D is 4 and C is 1. And yes, you do have to show work. Sorry. It's so much work.
Oh my.
So D is what? 4. And C is 1. What math am I going to do with that? Subtract, because distance is subtraction, right?
Yes, we wrote that down.
Okay. So it is 3.
I knew that. I didn't
Now,
look
if
it
you
up.
would have said 1 minus 4, you would have had -3, but it is the what? Absolute value, so it is still what? 3. If you always do the larger minus the smaller, will you ever have to worry about the absolute value? No. Okay. So what is the length of AC? So C is C is 1. A is so minus a -3. Did you watch how I just wrote that?
Yeah, plus.
I
You changed the
I subtracted a negative, but I did it when I said it, didn't I? Because this right here makes me kind of throw up in my mouth. It's gross.
It really is still a plus sign, though.
Yeah, it is, but it's clutter. But when I do it, I just go 1 minus a -3. And I say it in my head every single time. Because do two negative signs make a positive? Yes.
Did you even hit record?
Yep,
Are you sure?
it's recording right here.
Pause.
2 minutes and 48 seconds.
Okay.
Okay, so AC is how long?
4.
4. And if there were units, I would need to put the units on there, correct? Okay, so I want you to try BD and 80 on your own.
BD. 0.
Okay, on your own is quietly on paper, not out your mouth. Whoever's clicking, can we stop? Hopefully that made it a little brighter on the screen. Okay, so D is 4 minus 0 is 4. And AD is 4 minus a -3, so it is 7. Good? Okay, so on your line, mine is very small. Is yours a little bigger?
No.
No.
Okay, So this is an A, this is a B, and this is a C. So if you can't see it, just write it on there.
It's all on there.
Okay. So segment addition postulate. A postulate is a rule. It is a rule that it's okay. We have things called theorems in geometry, and it is no matter what that is true. It doesn't. It is true. It has been proven that it's true. A postulate is something that has been used to prove something is true. Does that make sense? So a postulate essentially is a rule. So if there shouldn't be an F there, my F didn't show up. If the segment A, B, C, because that's what that is, then collinear points lie on the same line. Okay, the definition of collinear, guys. Co means they share, yes. Linear is a line. So the word collinear implies they are on the same line, correct? So all it says is basically if you have this picture, they're collinear and they're on the same line. Duh. Can we all say duh? Okay. But you know, we got to spell things out. So if F, G, H are collinear. Now in your book, they're going to have words like this. They're not going to have a picture. You're going to have to draw the picture. So it says F, G, H are collinear. If it doesn't say that G is between or H is between F and G, it is on that line F, G, H. Does that make sense? It's like sometimes it will say the points F, G, H lie on the same line and H is between.
There was one like that one.
Okay, so if it doesn't say anybody's between anything, you put them in the order they're printed. Make sense? So they're collinear, so I'm drawing a line without a picture. I'm drawing a line that says F, G, H. Try not to make them equally distanced because you don't know. And if we put them right in the middle, what does our brain want to do? Cut it right in half, correct?
No.
And we cannot, unless we have a theorem about it or it tells me, we cannot assume anything. And never trust a picture. Only numbers. Does that make sense? Don't look at the picture and go, it looks like a square. Gotta prove it. So I did give you a line, but I wanted to show you how we make that. So it says GH is 16. I would highly suggest you draw the pictures on your paper so you can write on them, not on my book. So G to H is how far? 16. So I'm going to write a 16 here. So I know that that is 16. What is FH? So I want to know
H is 15.
what the whole thing is.
7.
Okay? Now, I am going to tell you right now, they wrote, this is their words, and FH is wrong. Why is FH wrong?
Oh, because
What's
that's
it missing?
the H
Nope.
Line.
It's
tab. Line
missing
over.
that over it. So should you put it over it?
Yes.
Yep. Okay, so I want this. You should approach every single one of these problems in geometry like a puzzle. It's a problem to be solved. Now, I don't want you to start trying to calculate it and manipulate it and guess and check. I want you to come up with a plan. So if I want this whole thing, if I want FH, in general, what do I have to do?
Figure out what F to G is.
I need to figure out what F to G is and do what with it?
Add it to 16.
Add it to, no, we're doing letters, so add it to what?
G and H.
Okay, G and H. Do you see how I'm doing letters? I'm going to stick with letters. So I essentially need to figure out what FG is and add it to 16. So do we have a plan?
Yes.
Okay, so now we have a plan, and now we have to figure out how we're going to figure out what FG is. So we have 16, right? What else do we know about 16? What, look on your paper. What else does it tell you about GH?
Is the distance
2x plus 2.
It's 2x plus 2. Is GH not 2x plus 2? And if I know the whole thing is 16, what can I do with 2x plus 2 and 16 that can help me out?
Try to find the
7 equal to
coordinate.
each other.
Find x.
I can find x. Why finding x is it going to help me?
So that way
'Cause then you can put
find
it
the x
into
on
Because
there.
I can put it into there. Okay? So are these problems going to be a straight do this? No. You got to think about what do I have to eventually do and how can I get there? So I went here, I got to find FG. Well, I can't find FG unless I have x. Can I? But I do have 16 and I do have 2x plus 2. That equals what? 16. So I can set up an algebra problem. 2x plus 2 equals 16. Again, very basic ones, yes, but some of them won't be, so write it down. So I'm going to subtract 2. So 2x equals what? 14. So x equals 7. Now, I showed work without subtracting 2 and dividing by 2, did I not? Yes. In algebra, did you have to show minus 2, divide by 2? You don't have to in here, but you have to at least show me your steps. Yes. Okay, if you want to do the minus 2 and divide by 2, that's fine, but I'm asking for just the bare minimum. If I can't figure it out, you subtracted 2 and divided by 2, I got problems, correct? Okay, not teaching you algebra anymore. So what am I going to do with this x now?
Put it in.
Plug it in there.
I'm going to plug it in here. So FG, do you see also how I'm labeling all my work? So when Mrs. Mick reads my work, she's not straining her brain. So 3 times 7 minus 1. So FG equals,
21. So 20.
so 20. And if you need to write 21 minus 1, okay. So 20 plus 16 is
36.
36. And I have my FG here, and it equaled, and it equaled. And if you want to put it over here, can I put it over here so you don't forget what it's equaling? Yes. Where's my final answer? Right there. I'm not a huge one that says you have to box your answer, but I have to know what your answer is.
Please circle
I
it.
circle it.
You can circle it. If you do all your work always down, am I going to know what your final answer is?
Yeah.
Yes. I will tell you that when I grade papers, it is not like a seek and find. It is not a Where's Waldo book. I'm not going, the answer's 1/2 and I see it there. That's not going to happen. Whatever looks like the answer, that's what I'm going to grade. Does that make sense? So it is time for you, because some of you are disorganized in your work, and I know that. So it's time to grow up and mature in how I display my work. Okay, so the next one I want you to try, F, G, and H are collinear. JL is 39. What is FH? That should not be FH. That should be...
Mine says GH.
No, yours is different. I tried to fix some mistakes. Okay, so this should be J. See, there's some mistakes. I need to go back and finish, right? K, L. You got a picture, right? You can use that picture. JL is 39. I did fix that. We are gonna, I want JK and KL.
Mine says if.
And I don't care what yours says.
Change the 16 to 39.
Yep. So change that. So you did JKL. JL is 39. I need to go back and fix more. Fix.
What is JK and KL?
Yep. So all right, you guys tell me. What do we think we need to do? Should I like write here so I know like this whole thing is what? 39. So that gives my brain something to look at rather than keep going back, right? and I need to find both JK and KL.
Well, JK is 3N, so.
Mm-hmm.
So you need to find 5n minus 7.
You
Yeah,
divide
which
3
is
by,
KL.
you divide 3 by 39. Well, you divide 39 by 3. Yeah, divide 39 by 3. And then you have 13.
But 3n doesn't equal 39.
13.
Yeah, you would have.
What does 39 equal, guys?
The whole.
JL.
It equals JL, yeah?
Yeah.
So go backwards from that. What made up JL?
Add the
3
two
and-
together. So-
Add the two together,
so we
correct?
have 8
So
and-
JL, so we can see it, equals JK plus KL?
No.
Yes,
Yes.
doesn't it?
Yeah.
Yeah.
4.
So we know that much. So do we know what JL is?
Yes.
Do we know what JK is?
No.
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 Do we have an equation for JK?
3N.
3N.
Look at your paper, it would be easier to read than that. 3N. Okay, do we know what KL is?
5N minus 7.
Okay, so can we just replace these things with the things we know?
Yes.
Yeah.
Okay, so JL is
39.
39 equals, what's JK?
5.
3N. And what math are we going to do with these two pieces?
Divide. Wait, no. you-
Plus.
Plus.
Addition.
We're just filling in this equation we made. We made an equation with
Oh.
segments, yes?
Yeah.
Now we're filling in our algebra, and then we will solve our algebra. And then plug it back in,
Plus
right?
5N
So
minus 7.
then
Plus
5n.
minus 7.
So it's n equals 1.
So it's 39 equals
8 minus 7.
8n minus 7.
Okay.
You got to show me that.
To the
So add 7 and I get 46.
46. Yeah, 46.
Did I really mess that up again?
How does it go evenly?
Well, if you.
No, it wasn't.
Yeah.
Make this 9. Make this 9. I messed it up again. I subtracted instead of added.
No.
Okay, so if I make that 9, that makes it 48. Yes?
Yes.
Okay.
Equals 8.
Equals 8n. So n is 6.
Not bad.
Yeah. 8 times 8 is not 48.
Yeah.
Okay, so now what am I going to do with this?
Plug it into the
Plug
Plug
separate
it into
equation.
JK.
Plug it into JK.
And then plug it
So JK
Equals
equals 3 times 6, so it is
18.
18. And your units, if you have any, I keep pushing that because you'll miss a half a point of problem for no units. Is that, like, that's silly to lose, right? Okay, KL.
That
You
equals
plug
23.
the.
So 5 times 6 minus 9. So 30 minus 9 is
21.
21.
But if you add JK and KL together, it'd be 41.
But you don't do that.
Yeah, that means
Oh.
JL would.
I made my numbers. I changed this number, and what did I not change?
That one.
That one. So just, it's fine. Yes, normally, Axel, this is what you get by changing things on the fly, right?
Yeah.
Normally, Axel says we add these two together and check our work, yes?
It equals
Yes.
39.
What?
21 plus 18.
Yeah, they do equal 39.
Yeah, but I looked at my thing and it was a 7. I forgot.
Oh, you forgot to change it. Okay, so should I mentally go 18 plus 21 is 39? Yes. Do I have to write it out anywhere? No. Should I stop and check my work from time to time?
Yes.
Yeah. Okay.
That's what I do.
Okay, next. This is called anybody. Mine picture is much better than your picture. So look up here, but look at your numbers when you're reading it. Because you can see your numbers, you just can't see the thing. Okay, I'm not going to tell you, I keep saying the thing. What is this thing called?
Protractor.
A protractor. Protractors can look like this, right? They can look like this. They can look like this. Okay, they all work kind of the same. So, see this dot right here? Okay, so this dot goes on the vertex of the angle. This line right here, whichever way it goes on the the bottom ray, or it goes on one of the rays. It doesn't really matter which one, okay? So you would put it here, and I usually put my pencil to make sure I've got it right on the tip, and I line it up, and then I could measure. Would this one be hard to read? Like, yeah, because the lines aren't extended, are they? So if I only had this one, I'd probably be better off extending my lines,
Yeah.
wouldn't I? Okay, Brooklyn, can you put your head up? Thanks. So this one works this way. This arrow right here sits on the vertex, and the bottom ray goes right here. So I would line it up. And this one's better,
Yeah.
but still a little hard to read because you can't see through here, can you? So again, would it be better off to extend it?
Yeah.
Yeah, but these are my favorite. This is probably the oldest, and I do have some of these that are clear also. But now look at this one. Dot, bottom, so dot, bottom. Now, I can't see very well, but can I see everything through there?
Yeah.
So any one of these, I probably need to extend my ray, don't I? Now, you can't extend your ray in my textbook. Got me? I want no drawing, writing in the textbook. Usually when I have you measure something, it's on a piece of paper, not in your textbook regardless. Okay? If it's in the textbook, it would be a picture like this. Make sense? Okay, so I want M. M always stands for measure. When you see a lowercase m, it's not angle M, it's the measure of the angle. Got it?
Oh, that makes sense.
So, like if they wanted the measure of angle A, they'd write it like that. Okay? So, can you look on your protractor and tell me the measure of AEC? Remember, E is the vertex. So, AEC. What do you get?
It would be 105.
105, you agree? You guys kind of see it on there? I know it's a crappy copy. You definitely cannot see it looking at the board. You have to look at your paper. So I write 105 what? Degrees. That little circle will bite you in the butt every time. If you don't put it there, it's a half a point. Gone. Is it important? Is degree a unit? Yes. Now, it is not a temperature degree. It's a degree of an angle. So don't put Fahrenheit. I had somebody a couple years ago. Fahrenheit. How do I know if it's Fahrenheit or Celsius? It's not a temperature. I thought I was a failure as a teacher. Okay. So we said this from here to here, like this whole thing right here, right? Was 105? Okay. And see how I draw that this like this? And it started, we usually call these the, I can't think of the word, initial ray, and it actually is moving to the terminal ray. Ever heard that word terminal somewhere?
Yeah.
Where?
Like at an airport?
An airport. You know why it's called an airport terminal?
And
You terminate there. And if you're in terminal condition, what are you going to do? Die. You're terminating. Okay, so this is called, what actually is happening with an angle is you start this ray and you see the movement of that ray. Isn't that kind of neat? Okay, so we need BEC. So BEC. Wait a second. We need in here, right?
Yeah, it's 58 degrees.
No, sometimes I forget you have erasable pens.
You forget that I have erased.
That's kind of cool.
Okay. So, how are we going to find BEC?
You
you
take
get-
45
you
and
get both
you
of
take
them.
105 and subtract it from 45.
Subtract.
You're going to take AEC, right?
Yes.
So angle AE. I think I need a new blue pen. C. And you're going to subtract what angle?
wait,
BEC.
yeah.
No.
B.
How about this one?
Oh,
Oh,
hey.
yeah.
Yeah. AEB.
Yeah.
Because this middle one is not like, if I took my protractor though, and I moved it like this, could I just measure what I needed? Yeah, but I can't do that because they gave it to me. Okay, so what was AEC?
105.
105. And what is AEB? This one's a little tricky, guys.
45.
No, it's not 45.
48?
I'd say 47. I agree. I think 47.
47.
Yeah, because 45 is this tick here. I think it's about 47. Now, is that exact? No, I probably would accept 46, but I wouldn't accept 45.
48?
Nope. It'd be closer to 50 if it was 48, wouldn't it?
Yeah.
True that.
Okay. So minus 47. So 7, 15 would be 8, 9 would be 5, 58 degrees. Okay. So we know from here to here, this blue is 58 degrees. Do you see how beneficial it could be to have paper and be able just to like mark it up? Yeah, not your textbook. So if you want to mark it all up, you got to draw pictures. Who do you need?
Miles.
Why did you have to do that for the second one but not the first one?
Because the first one, the first ray was the bottom, and it went to here. So we just moved from here to here.
I have a question.
But this one's in the middle of that, and so I don't have that. It's not measured from the bottom. It was measured.
So you're
Just one.
finding the angle inside of it.
Yep, we found the angle in between. Like this is the big angle. This is the little angle. I want the difference between
So for
them.
the next one, you're gonna find the smaller angle.
So the next one, I want BED.
So you want
Bed.
I want. Let me get purple.
Why can't you just see what the degrees are and subtract them from each other? To know?
That's what you're doing. It's easier this way. It's just easier this way. Because it switches here and people, well, because this is the 105, so you can't see that. Like, that degree isn't correct to just subtract from this degree. You wouldn't get the same answer. Not, I mean, here we will because we're right here. But if it wasn't right there, like this next one, it wouldn't work. Okay, so now I want BED. What am I going to have to do there?
Measure.
Add it on. Add the CD.
There's add.
Or you-
add,
So if I have BEC,
just add.
Add.
C to CD.
CED, okay? So we're going to take angle BEC and add it to angle CED. But first we have to figure out CDE. So how are you going to figure out CDE? So CED, how are you going to figure out it?
Probably just add them, you know? Just like add like 5, 10, 15, 20, 25. It'd be 25 degrees.
25, yeah.
Okay, but I don't want to count because, you know,
Lazy.
how about some math, some solid math?
BED.
Counting is solid math.
Do we know this to here is 105?
Yeah.
So do you know from here to here? Could we figure that out?
Yeah.
So what could we do with this and this? Not add,
Subtract.
subtract. If I have this and I have this, I subtract and get the middle piece, yeah? Okay, so what is this?
130.
130, so 130 minus 105 would be 25. Now, what I'm saying is, what happens if they aren't perfect on things? Do we count wrong sometimes?
What's perfect?
Yes. Okay, so I know this is 58 and I know this is 25. So what do I do with those two?
Put them together.
Add them. So 28, not 28, 58. I added the 2 from the other one. 58 plus 25 is
83.
83. Now, guys, if you were doing them the other ways you were doing them, that's fine. I'm just trying to get you to look at ways that when things get more complicated will always work. Does that make sense?
Yeah.
As long as I know how you're figuring them out, I'm good. The only one we didn't find was what? Oh, we found it, but we didn't label it. What was this one?
180.
No, it was 47.
47.
Okay, and that was an estimate, right? All the rest were right on. Okay, so angle addition postulate. Okay, so we have an angle addition postulate. And I lost the paper. But you think it's going to be kind of a duh, like the other one?
No,
You don't think so?
no.
Okay, it says angle addition postulate. Might want to underline that. If you have an angle like this, so B is the vertex, yes?
Yep.
And CBD is an angle, DBA is an angle, CBA is an angle. There's actually 3 angles there, right? Okay, so you have that. Then the measure of angle CBD, so CBD plus, not equals, should be plus, sorry, plus the measure of angle ABD equals what? If this is CBD and this is ABD,
CBA.
It would be equals CBD. CBA.
ABC. Because the 2 little angles equal the what? Big one. Did we just do that up here in this example?
Pretty much.
Yes.
When it equals CBA.
But why do you start with C?
Alphabetical.
Oh, yeah.
A, B, C. Okay, what always comes in the middle though?
The starter angle.
What is that? What is this thing?
Vertex.
Vertex.
Yeah.
Always the vertex. The side has to go alphabetical, but always the vertex in the middle. Got me? Okay, this one so happens that it was just ABC. But like if the vertex was F, it would be AFC. Okay?
AFC.
So, if the measure of SPR equals 60, so what should we do with that information?
Put it down.
Like we should write it on here, right?
Yeah.
So SPR is 60. And I do this. I go like this and I put a 60. And a degree can even be a dot when you're writing it on there. The measure of SPQ, so that's what? That's the whole thing. So draw it the what? Whole way. Is 119. I bet you can guess what they're going to ask for.
Subtract.
They want the
They want
QPR.
They want
The little one.
QPR. So they want this one right here.
The bigger
You
one.
subtract.
Okay, so our plan is, and we're just doing this so we have it back in our memory, right? So the measure of angle QPR equals,
59 degrees.
nope, the measure of angle what?
Angle
SPR.
SPQ
SPQ? How about QPS?
QPS.
QPS
Minus
minus the measure of angle
SPR.
RPS.
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 What do you put it back?
What do you mean? Why do I put what backwards?
It's in alphabetical order.
It's in alphabetical order.
You're trying to tell her to put it backwards.
No, I asked her why it was backwards because in the instructions, like in the question, it's not in
It's in
alphabetical order.
alphabetical.
Ow.
Well, it should be. Those instructions are out of the book. They should be.
Oh.
Okay. The book does a lot of things that they shouldn't do. Okay, so what do we got? What's QPS?
QPS is
160. I mean 60.
119
Oh, 119.
minus
60.
60. So I get 950, 59 degrees.
That was easy.
Yeah, they're not hard.
Why did I cry about this to my mom yesterday?
Don't know.
My mom.
I cried.
Drama
but
queen. No.
I
Okay.
cried
Yes,
and my
she
mom,
is.
I was like, Mom, your is way too hard. I'm gonna fail.
It is not. Okay. So now we have an application problem. Okay, I know you love application problems. And you don't call them application problems, you call them what?
Word problem.
Word problems or story problems. I had a math teacher one time that said, no, we're going to call them application problems. This is my theory. If you cannot apply what I'm teaching you, what is the point of me teaching you? Correct?
Correct.
The other thing is geometry is one of the most applicable maths out there. Because would we have the building that we're in right now without geometry?
Yes, very much so.
Yes, it would have been a lot more difficult.
No, it wouldn't happen. Like you would not have right corners. You would not have like
It would not be
The building
yeah, it would not be square. It would not be. It would. I would not go into a building that was not built with some geometry. Okay, so we got a big story here. We got some information. Your picture is probably easier to see than mine, just because we're at. I don't understand why it's like not focused.
Focus.
Okay, so follow along on your paper. Okay, a lighting designer. Oh, also, if your picture wasn't here, I always suggest that you draw your own. But I don't think I would put a light or a chair. I would put a C for the chair, right? An R for the rug, a D for the door, a T for the table.
They don't draw
And just-
pictures.
Right. You draw pictures, but not artwork. Okay. A lighting designer is finalizing the lighting plan for an upcoming production. The spotlight can rotate 25 degrees. So here it can go this way 25 and this way 25. To the left and to the right from the center. The beam of the light from the spotlight forms a 22-degree angle. So like right here, see how it has it 22 degrees? Okay. Can the designer use the spotlight to light each of the objects on the stage?
No.
Okay,
You have to figure that out.
you have to figure that out. So how do you think we're going to figure it out?
I have no
So first of all, we need to make sure we know everything we're looking at, right? Okay, so 74 is this whole thing, correct?
Yep.
Okay. 57 is just from the left to that second to last line, yes?
Yes.
And 22 is just this little area right here. So we good? Okay. So well, now think about it. I've got my if I'm pointing my light straight ahead, yes? It goes out from 0 to 22 degrees over. But what can I do with my spotlight?
Move it.
I can move it how much?
25 degrees.
25 degrees to the right or 25 degrees to the left.
So we gotta figure
Okay,
out
but
the
when
first
we
one
were
last.
talking 25 degrees to the right or to the left, when I go, okay, never mind. So we need to figure out what.
The very first one and the last one. If it's 25 degrees to see if we can move it.
Okay. So how are we going to do that? So we need to obviously we can get the door and the rug, yes?
Yes.
Okay. So our questionable ones are the table and the
Chair.
chair.
You could do the first one by subtracting the 57 from 22. Or, yeah, 22 from 57. Can't you?
Okay, so if you take 74 minus 57, you can get this one. Is that what you were wanting?
No, the first one, which is like 57 minus 22, so then you get the very first one with the chair.
You don't know that. Because 57 minus 22. Oh, I get what you're saying. Okay, never mind. I just had to think. So right here, for this and here, we're going to take 57 minus 22 and get
435.
35. Okay. How much can I move that thing?
25.
22.
22. 22 is what it does.
25 degrees.
So I can move it 25.
Yeah, so no.
So no, it can't reach all of the objects on the
The
stage.
chair, you can't reach the chair.
Yeah.
It's 10 degrees too much.
It's 10 degrees too much, isn't it?
Yeah.
Okay, so no chair. Oh, I probably should write complete sentences, right?
Chair.
Can't reach the chair because what?
It's 10 degrees too much.
It is 10
Actually,
degrees too far. And that's 2 O's, right?
Yep.
Okay.
Oh.
So then, how am I going to figure out this one?
74
74
minus
minus
57.
74 minus 57 will get me just right here, right?
Yeah.
Yeah.
So 74 minus 57.
17.
You guys
Hey,
agree?
You have enough room.
Okay, can I get the table?
Yes.
Yes.
Okay,
You could
but you can
Get the table.
get the table. Now, and you could say with so much left over if you'd want. But I have my answer. Do I have my work?
Yes.
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 And then if I would have drawn a picture, I don't have to do any more explanation with that, do I? But if you didn't draw the picture, did you have to do some more writing probably? Yes. Okay, that's probably not even our last page yet.
We have one more.
Okay, so
We're so good.
again, you have hopefully this answered all your questions on yesterday if you had any. Okay, now the assignment that is up there, it is page 12, right? 12, 16 through 38, and 39. So that is your assignment for tonight. Again, go as far as you can. What is my heading? Upper
your
right
name-
hand corner.
Your name and
Name.
the page number and the questions.
Section is what?
1.1.
1.1.
11 slash 16 through 38 and 39.
Is it 11 or 12?
12. I mean.
12
I was thinking of yesterday's.
slash 12, comma 16 through 38, 39. Okay, when you finish both homework assignments from yesterday, shush please, so I don't have to talk over you. Yesterday's assignment should get turned in today, right? Today's assignment, if you don't get all the way through it, we'll finish it up tomorrow because our notes won't take us that long and we'll have time in class. But if you don't start your assignment tomorrow, guess what you have over the weekend? Homework. So start your homework and do what you can so you can finish it in class. Okay, have a wonderful day, guys.